At the center of our stellar system, shining in our sky, we all know how dependent we are to our star. But have you ever asked yourself how it works? This is Mohammed Amine, and I'm here to talk to you about the sun. This fireball is mainly made of hydrogen and helium as gas and plasma. Well, plasma is the fourth state of matter. Unlike gas and the others, where the electrons are rotating around the nuclei of their atoms, the atoms in plasma are ripped of their electrons, and everything is just freely flying around. Let's take a look at the layers of the sun. There is the atmosphere, which consists of the photosphere, the chromosphere, a transition region, and the corona, while inside we start from the convective zone. It's called so because of convective currents. The particles exposed to heat from the lower layer expand. This gives them less density and rise up, letting cold particles take their place. We can demonstrate this with a little experiment. We need some boiled water as a heat source, some paint to colorize the water, and of course some water for the experiment. We put our heat source under the water, then we colorize the water with some paint so we can see it moving. Now we let the thermodynamics do their job. You can see the hot red water rising up while the cold blue water comes down to replace it. And that's it, convective currents. After the convective zone is the radiative zone, with the interface layer between them. This thin layer is significantly important for the sun's magnetic field, which protects us from cosmic radiation, and that's something we wouldn't really like to reach us. Back to the radiative zone, it's basically the layer where the energy coming from the core is transported as electromagnetic radiation, which is just a cool name for a stream of photons, like light. Because of the density of this layer, the photons take their time bouncing for hundreds of thousands of years before getting out. And there it lies, the heart of our star, the core of the sun powered by fusion. The plasma there is so hot and so dense that the nuclei of the atoms, even though they normally repel each other because of their positive charge, can collide and make a new nucleus. This process is what's called nuclear fusion. Because the resultant nucleus has less mass than the two before, the lost mass is actually converted to energy. This energy is what gives us heat and light, which are quite critical for our existence here on Earth.